Welcome back. This is section 8.2.2. This is confidence interval for population mean and population standard deviation known. So please, I highly request you all to have your pen and paper ready. I will leave a copy of this particular PDF in Blackboard so you can download it and work with me. So in the previous sections, what we did was we found out the margin of error, we found out the point estimate. Now we're going to go backward. We will have the point estimate, we will have the margin of error, we will have the confidence interval, we will have the confidence percentage. We need to calculate the confidence interval. Again, keep in mind what confidence interval is. If you are 95% confident, let's say the percentages, that your confidence level is 95%, you're telling me I am 95% confident that the population mean falls in this interval. So it's very important we understand what this means. So if you are confused about this one, I highly request to go back to the previous sections videos. Just give yourself a quick recap of what is a confidence interval, what is margin of error, what is point estimate, and what is your confidence level in percentages. All right, so now let's go ahead and jump right into it. So here, the first few things that you have to memorize or you have to remember is what is a confidence interval? It's the region formed between a point estimate minus the margin of error, that's your lower limit, and point estimate plus the margin of error, your upper limit. Remember, you are giving me an interval. So interval has a lower limit and upper limit, and your sample mean is exactly in between. Your margin of error is the difference between your sample mean and your point estimate. Margin of error is sometimes referred to as error bound, or it's also abbreviated as EBM. And in this particular section, I put your margin of error as ME, so I can save some space. Significance level is the probability of rejecting null hypothesis when it is actually true, equal to 1 minus confidence interval. So what the significance level means is it's represented by a symbol alpha. Let's say you are 95% confident, then your significance level is 5%. So 100 minus 95, because you always give yourself some room to make mistakes in statistics. Fair enough? So if you're 90% confident, your significance level, your alpha level is 10%, which is type 1 error, which is a false positive. We will be looking in detail as we go deeper into the topic, but as of now, your significance level is 100 minus your confidence percentage. So if you're 95% confidence, your significance level is 5%. If you are 99% confident, your significance level is 1%. All right? Okay, so the next is how to calculate your confidence interval. There is a formula for it. So point estimate minus margin of error, point estimate plus margin of error. And the formula for margin of error is given, Z alpha divided by 2 times standard deviation over square root of n, where n stands for sample size. In your classwork or in your textbook, all this has been clearly explained and worked out step by step. What I'm going to show you is how to calculate your confidence interval using your ClassCalc. So let's go ahead and open up ClassCalc. But before we do that, let's take a look at the first example. It's very important we understand what we are doing. All right. Let me get my highlighter. There you go. Suppose, where is it? Okay. Suppose heights in inches of orangutans are normally distributed. Again, I will go ahead and highlight everything that I think it's point of interest to me. Normally distributed, I know it is a normal curve, right? And a known population standard deviation. Known population standard deviation of 4 inches. So I know my standard deviation of population is 4. An unknown mean. Okay, so the mean is unknown. So I want you to take a step back and think about this problem. So we are trying to find, suppose the heights of orangutans are normally distributed. So I know they are normally distributed. I know the standard deviation of the entire orangutan's height, but I don't know the mean. Keep that in mind. So I take a random sample of 16 orangutans and so once I take the sample, I calculate the height of every orangutan and I get the height as 56 inches. Find the confidence interval. So tell me, hey, give me the interval between which the population mean within 95% confidence interval. It is very important we understand what's happening in the problem. Once you understand what's happening, you can solve the problems as you go. Step one, I am trying to calculate the mean of the entire orangutans in the world. So I don't know what the mean is, but I know what the standard deviation is. Standard deviation is 4 inches. Inches? Yes, 4 inches. So what do? I take 16 orangutans. I'm very brave. So I take 16 orangutans and I calculate the height. When I calculate the height of all those 16 orangutans, I get the sample mean as 56 inches. Now I'm asking you, from this information, from the standard deviation, from the sample size, and from the sample mean, I want you to tell me, what do you think the average height of the orangutans will be? And I do not want you to give me a point estimate. I want you to give me an interval, right? And I also want you to be 95% confident. So that means your significance level is 5. Remember, significance level is always 100 minus your confidence, which is 100 minus 95 is 5%. Now, what I'm trying to ask you is, give me an interval of where the orangutan's height, you can tell me, miss, the orangutan height is from this to this. But when you give me the interval, I want you to be 95% confident. So you're telling me, I am 95% confident that the average height of any orangutan, the population mean of orangutan, will be in this interval level. All right? So that's what you're doing. You know the population standard deviation, you know the sample size, you know the sample mean, and based on these three, you are giving me a confidence interval and telling me that the 95% confident that the orangutan height is going to be in this interval. Now, once we know that, let's go ahead and write this down here. Please make sure you follow the same steps so it's easy for you when you're working your problem out. So standard deviation of the population, I know standard deviation is 4 inches. Sample mean, I got 56 inches. Sample size, I know it's 16. Confidence level, how confident are you? 95%. I am also going to include alpha, so you get used to significance level. So if you're 95% confident, your alpha is 5%. Remember, 100 minus 95. Now, once you have this, if you want to do it mathematically, you can go ahead and follow the steps in your textbook, but I want to show you how to use ClassCalc. You go to graphing calculator. I have given you the steps, stats, test, z-interval, and stats. So let's go ahead and open up our ClassCalc. Where is it? So here I have my ClassCalc. You will make sure you start with graphing calculator, graphing. And then I will go to stats. Let me expand this one. So graphing, stats, you will click on tests, and then you will click on Z-INT, Z-interval. Everybody with me? Let me repeat that. Graphing, I'll close this one. Graphing calculator, stats, tests, and then Z-interval. And once you click Z-interval, you will see that this little icon pops up where it says Z-interval with 4 blocks for you to fill up your answers. And once you have that, let me expand this one so you can see. There you have it. Right? I'm going to go ahead and plug in all the values that I have. I know, and the way you plug in is given to you right here. So the first thing is standard deviation. The next is sample mean. The next is sample size and how confident are you. So let's go ahead and plug that in. I know my standard deviation is 4. I know my sample mean. And again, make sure you are in stats, not in data. Stats is you giving me the sample mean. Data is you giving me the raw numbers. I don't have any raw numbers. Do you have all the 16 heights of orangutans? No, you don't. You just have the statistics. So you just have the mean. So sample mean is 56 and sample size is 16 and confidence interval is 95. Yes, so it's 0.95. My shoulder has been hurting really bad. Okay. And once I do that, let me expand this. Once I do that, I don't know why this is going to that level again. Okay. And as soon as you do that, you will have your confidence interval right here. So as you can see, my confidence interval is 54.040036. That's my lower limit. My upper limit is 57.95. That's correct, right? I mean, that makes sense. So if I take 16 orangutans and if I got their height as 56, my confidence interval has to be somewhere here. I cannot have 100 inches or, 150, not way too far, right? And the margin of error, you also get your margin of error right here. So keep in mind, once you plug everything, you'll have your confidence interval and you'll also have your margin of error. So I'm going to move this to the side here. And I'm going to pull this up and I'm going to go ahead and let me see. Yep. I don't know why I'm doing this, but let me go ahead and split the screens. There you go. That's much better. Okay, once I have that, I'm going to go ahead and write my confidence interval. So my confidence interval from here is 54. Again, depending on how many decimal places they ask you to. I think this is, I'm going to keep it to 2 decimals. 54.04 is my lower limit and 57.96 is my upper limit. So with one click of your ClassCalc, you have your lower limit and your upper limit. But if you want to do it using formulas, the formulas are right here. You have the formula for margin of error. You have the formula for confidence interval. You find your margin of error, simply add it to point estimate and subtract it from point estimate. Okay? All right, all right. So now let's just say, where's my margin of error? I also have my margin of error. I'm going to write that down as well. My margin of error is, what was it? Let me scroll this down. Da, 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 da. That is 1.96, rounding off to 2 decimal places. So I also have my margin of error from right here. So I highly recommend using your ClassCalc if you are having problems with plugging in the right formula or doing stuff like that. I highly recommend using your ClassCalc. All right, let's go ahead and do the next problem. See how easy it is using ClassCalc? All right, where is my next one? Okay, so I'm gonna move this one just a little bit to this side. Okay, there you go, perfect. All right, the weights in pounds of dogs in a city are normally distributed. Again, where is my handy dandy tool? My highlighter. Okay, I have that. So the weights in the dogs are normally distributed. Again, keep in mind, majority of the data that we take will be normally distributed. Population standard deviation of 2 pounds. Population standard deviation of 2 pounds. And mean is unknown, same like before. A random sample of 16 dogs. What's with 16? They took 16 orangutans, now they're taking 16 dogs. And they took a random sample of 16 dogs, and the result of the sample mean is 28 pounds. Identify the parameters needed to calculate the confidence interval at 90% confidence level. In the previous case, they wanted to be 95% confident. Now they want you to be 90% confident. So I'm going to use my handy dandy tool here. I'm going to fill up what I know. X bar stands for sample mean, right? X bar is sample mean. What's my sample mean here? I took 16 dogs and the mean was 28. So my sample mean is 28. Standard deviation is 2 pounds. Sample size, N is your sample size, which is 16. Next one is Z alpha. The next one is Z alpha. What that means is, let me start with my confidence interval. So my confidence level is 90%. So my alpha, my significance level is 10%. And we're going to talk about left tail, right tail, and two tail as we progress into the course. But as of now, we are trying to find the z-score of alpha over 2. What that means is 10% over 2 is 5%. 5% in decimal is 0.05. So alpha 0.0, oop, that's a perfect circle. Alpha 0.05 is right here. So that is your alpha 0.05. You will go ahead and plug that in. You don't have to calculate this one. All these tables will be given to you. So alpha 0.05 is 645. And they're asking us to find the confidence interval, right? Again, to find the confidence interval, I will be using my ClassCalc. So what I will do is I will go ahead and erase this one. Always, always, always erase what you have and start from the beginning. It makes your life so much more easier. Again, graphing, I go to stats, I click on test, and I click on Z interval, and I will leave it to the default one, which is stats. The first one is standard deviation. In this case, standard deviation is 2, right? We just did it. Sample mean, I took 16 dogs and the average weight was 28. Ouch, my shoulder. Sample size is 16. And confidence interval, what's your confidence level? What percentage? You are 90% confident. Change that to a decimal, 0.9. And once you do that, here you have it. Your lower limit, I'm going to go ahead. My lower limit is 27.18. Rounding off to 2 decimals, I don't think I can write here. I'm going to use this one. 27.18. My upper limit is 28.82. There you go. So just use your ClassCalc to get your confidence interval. But if you want to go ahead and calculate, all the formulas are given in this worksheet. All right, so there you have it. Oh, I didn't know I created a space for this one, but let me go ahead and write that down. So my lower limit is 27.18, rounding off to 2 decimals. If your problem asks you to round off to 3 decimals, make sure you go ahead and do that. And I also have my margin of error. In this case is 0.82. Yeah, 0.82. So what do you think is happening? 0.82. So what do you think is happening? I calculated the mean of 16 dogs. So I got my sample mean as 28, right? This is my point estimate. So if I took 16 dogs and I calculated the mean, I got my point estimate as 28 pounds. Now I want to be 90% confident, and I'm going to say I'm 90% confident that the average weight of a dog falls from this level, from this point to this point. And how do I get those points? I simply add my margin of error. So as you can see, my upper limit is 28.82. What am I doing? Simply adding my margin of error to my point estimate. The lower limit is 27.18. What am I doing? I'm simply subtracting my margin of error from point estimate. So you're saying that you're 90% confident that you can catch the population mean, or the population mean of the dogs will be in this range. Now, having said that, it could be anywhere from 27.18 to 28.82. Okay? All right, all right. Let's take a look at the next problem. Okay, so the next problem is find the sample size required to estimate the population mean with the given confidence level. So you're going your way backward. They're asking you to find the sample size. So let's go ahead and take a look at the first problem here. The population standard deviation for the ages of Foothill College students is 15 years. Population standard deviation. So I have my population standard deviation. If we want to be 90% confident, I want to be 90% confident doing what? Let's see. That the sample mean age is within 2 years of the true population mean of Foothill College students. How many randomly selected Foothill College students must be surveyed? So look what they're giving you. They gave you the standard deviation. Let me go ahead and write that down. They gave you the standard deviation, which is, where is it? Where's the sign? Yeah. Standard deviation, which is 15 years. They gave you the confidence level, which is 90%. So if the confidence level is 90, I know my alpha is 10. Alpha over 2 is 5. I should put percentage. Percentage. Right? 5% is what? 0.05. So my Z 0.05 is 164. You see how easy it is when you do it step by step? Why is this popping up? Okay. No. So my Z from the table, this table will be given to you, so you don't have to worry about it. It's 1.645. So you see what I did? I start with my C level, which is 90%. 100 minus C level gives me my alpha. It's alpha over 2, which is 5%. Change that to a decimal, 0.05. Once I know that, go ahead and pick your Z-score. Standard deviation is 15. Now margin of error. I want you to go back to the problem. He says, I want to be 90% confident that the sample mean age is within 2 years. So this is my mean and it's within 2. So plus or minus 2. So plus or, this is minus actually. So plus or minus 2. What does that plus or minus mean? That is your margin of error. Give or take. Plus or minus, right? It's the error. So give or take, I have 15 students. So give or take 15. So when you say give or take, it's like, plus or minus, right? So margin of error, you want to be within 2 years of true population mean. That means your margin of error is 2. Now what they're asking you is, once you know all of this, they said, hey, I don't want to know the population mean. I want to know how many students should I sample or students should I survey. So I'm going to go ahead and plug that here. Z, I got it. My Z is 1.645. Standard deviation is 15. My margin of error is 2. What am I doing? Squaring everything. Okay. Let me go ahead, plug it into my calculator. Again, the best practice is delete everything you have. Open parentheses, 1.645 times 15 divided by 2. Close parentheses and then square. So I have 152.2. So this is 152.2. So how many, let's see, 0.21, yeah, 0.2. So they're asking you how many college students should you survey? So you can survey 152.2. So you always round up. So you will be, you will be surveying approximately 153 college students. So the minimum number of students you need to survey so that you are 90% confident and you're within 2 plus or minus 2 of the real population mean is 153. Okay? Again, simply use your formula, plug it in. Let's do one more. Da, 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 da. Okay. This is good. So what do I have here? Again, I get my handy dandy tool I always like to highlight. Suppose the finishing time of cyclists in a race are normally distributed. If population standard deviation is 16, so population standard deviation is 16. What is the minimum sample size? So they're asking you for n value. You need to be 90% confident. The sample mean is within 5 minutes, within, give or take, plus or minus, right? So let me go ahead and write down what information I have. Standard deviation is 16 minutes within 5, so my margin of error is 5. My confidence level is 90%. That means my alpha is 100 minus 90, which is 10%. So my alpha over 2 is 5%. 5% in decimal, 0.05. So I'm looking for Z 0.05. I think that was the same thing in the previous problem. You will always have this chart. Oops. Where is it? Where did I pick it up from? Yeah. You will always have this chart. So Z 0.05 is 1.645. Okay? So I know it's 1.645. This is 1.645. Once I know it, I'm going to go ahead and plug it into my formula, right? So that is open parentheses Z, which is 1.645 times standard deviation is 16 divided by 5 and whole squared. Again, I'm going to use my handy dandy tool here. I'm simply going to delete everything. Best practice, please, please, please delete. Open parentheses 1.645 times 16 divided by 2, close parentheses squared. It's 173.18. So what I get here is let me move this. My answer is 173.18. You always round up because you cannot survey 173.1 cyclists. I don't know what that means. So you will round up to approximately 174 cyclists. So your sample size, so the minimum sample size that you have to take here in order to be 90% confident and be within 5 minutes of the average time is 174. All right. Let's see if that's what we have. Da, 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 da. Yep, and again, if you have any questions or comments, please make sure you reach out to me through email or through Teams. Good luck.